Hello, Nina. Welcome back. How are you
Hello,
doing?
Garrett.
Today, I'm super excited because we're talking about chapter five, which is music is the jackpot, sensing, thinking, moving, feeling, which is the first chapter in the part two, our sonic selves. So, really, again, bringing this home to our human experience. When I was reading this chapter, I was thinking about this analogy about how music really engages and changes the sound mind. And I was thinking about like certain exercises, right? That can be, you can have a very limited exercise, maybe that just engages your bicep, like you're doing a bicep curl or something like that. But there are certain exercises like swimming or squats or walking that they engage your whole body, and they're considered better exercises for you. So I'm wondering if this is like maybe a an appropriate analogy for music, like something that engages the vast auditory system.
Yeah. Yeah, I think that's a great, beautiful analogy. Yeah, it works really well.
Cool, cool. Yeah, and I was just thinking like past its utility, even as like something like an exercise, music is something that just humans find inherently beautiful. And I'm wondering if, yeah, maybe this is too philosophical, but why do you think humans have such a deep relationship to music? What is it
Well,
about?
I don't think it's just humans. I mean, I think that music and the vibration of the spheres is something that is shared by most organisms. And so I really I think music was around long before there were humans to make it.
Yeah,
And so I really don't, again, I feel like we are, us humans are often so, it's not brazen, it's,
kind of like an arrogance or,
yeah, there's a
um,
tremendous arrogance, but there's a specific word that sort of means that I'm looking for. But yeah, that, it just seems so presumptuous to kind of put things in human terms, and so much biology is put that, and philosophy is couched that way, where the humans are at the top.
right?
And uh, I just think that is uncalled for.
I love all those anecdotes you have about even plants that, respond to sound in meaningful ways, and like a flower that unfolds for a certain bee's buzzing.
Yeah, at
Yeah, it's
particular
incredible.
frequencies. I mean, so much of the world is tuned to particular sounds. And all the more reason why it's so important to be thinking about sound and be thinking about music. And everyone is always looking to monetize different exercises and different ways in which you can strengthen this and that function in yourself. And we already have it. Music is something that we have a lot of access to, making music. And as you said, Garrett, I think it makes a lot of sense that making music is something that certainly exercises, um, almost every part of your brain and body. And um, and we have it. And you don't need some dumbass app to download.
Yeah, absolutely. There's a Japanese thing, Shinin-yoku, which is like forest bathing, but it's the most healthy things for humans are typically free. It's like walking out in nature, being around trees, all of this stuff that we take for granted because it's not, like monetized in an app that you pay a monthly subscription for. But it seems to be the most, healing thing is to be around kind of the natural beauty, whether that's, in the visual modality or in sound, like in music. And maybe it makes sense here to just touch a bit on speech versus music, because those are the two things that a lot of people think about in terms of organized sound. And I'm wondering if I know that there's one thing that I've always thought about is that speech and music, the kind of there are obvious differences in the categories. Like you can imagine like a Bach concerto or something like that's music, and then like someone like giving a lecture, like that's obviously speech, but they sort of fade into each other, like with
You sure
poetry or
do. And
rap.
then there's There's music that is sung with words.
Right. Right.
Yeah. And we, biologically, there's a lot of overlap, and there is also some separation between language and music. And I think Ani Patel has a really nice framework for thinking about this. He calls it the opera hypothesis,
Mm.
and he uses it to explain, why do you think that making music would strengthen your language skills? And so he says O stands for overlap. So there is a lot of overlap in, what it takes to speak and to create language and to make music. There's overlap in neural pathways. They both happen in sound. And so there's a tremendous amount of overlap, but he also, so the P in opera stands for precision. And he argues that music requires more precision than language. If you think that, we can understand each other really easily when speech is, we have a poor cell phone connection, or we somebody is speaking with an accent. We manage to figure out what is being said, but with music, very, very tiny changes in timing and frequency really disrupt the musicality a
Mm.
lot. So that, he argues that in terms of what circuitry that we utilize in our brains in making music requires more precision than language. And then E is emotion. Obviously, we learn what we care about, and there have been many, many experiments showing that if you stimulate the limbic pathways, emotional pathways, certainly experimental animals will learn faster, and we just know inherently that we learn what we care about. So the emotion really helps in the learning, and often there's a lot of emotion in music, perhaps sometimes more so than in language. Not always, but it does tend to be the case. So we have OPER. R is for repetition. So when you are making music, you are typically practicing something over and over and over and over and over again. And it is that repetition that is responsible for making some of the neural pathways that undergird music more powerful and stronger. So, because of the inherent repetition, that's very important. And then A is attention. You have to pay attention in order to make music, and um, strengthening. Attention is really one of the few things that we have to offer, if you will, to the world, each one of us as individuals. And so what we decide to pay attention to is very, very important and will very much shape our nervous system. So if you are constantly paying attention to your child, or to the therapy that you're engaged in, or the music you're making, the songs that you're singing, those neural pathways that are engaged in those activities will become strengthened. And similarly, if you spend all of your time engaging with screens or playing video games, those pathways also will become strengthened. And so what we decide to pay attention to is very, very important with respect to what we are and what we become biologically, because biologically, I like to say we are what we do.
Yeah. Ian has a quote that's like, attention is a moral act, I think. And yeah, your attention does change the world in so many ways.
Yeah, your attention changes yourself and it changes the world. So it's very much of a moral act.
Yeah.
It's funny. We in my class yesterday, I have the students take some point of discussion and discuss it among themselves, and then we discuss it as a group. And yesterday I asked them about McGilchrist's basic premise that as a society we are becoming more left hemisphere focused, in other words, more deconstructionist and more um, spending time and attention paying attention to things that are not alive, like machines and computers, and that this is something that has really escalated since the Industrial Revolution. And I asked them to argue, for and against his premise, and most people first of all, it was one of the discussions that just kind of kept going and going. The students were very, very excited and engaged in the topic. And I think that the overall consensus was that they agreed with him. And they also thought that his acknowledging this and making us aware of what is going on was very important and very hopeful because we are in a position to choose what we pay attention to choose what we do. And so, Ian's view is rather pessimistic, but a lot of the students were optimistic in thinking, well, now that I'm learning this and I'm thinking about this, um, it sort of challenges me to try to make the best decisions for what I pay attention to.
Yeah, it is lovely, when you call attention to something, when you give a name to something, it allows you to, I think, see it more clearly sometimes. Like when you're younger and you like learn the name of an emotion, you can like start to recognize that more in yourself. I think, you know, Ian especially has done something amazing in that like you can see this in like neuropathology, like with anosognosia or, someone who has a complete maybe right hemisphere is totally offline and they have a denial of their condition, like they can't see outside of their framing. He's like kind of pointing to this thing to help people see outside of the left hemisphere's framing. And yeah, it is funny to me too, and this is getting back a little bit, trying to connect it back to the speech and music thing. But, I was thinking that, speech being a left hemisphere function is a lot about, or it's mostly about representation. It's about creating the map. And whereas music is something that is almost like meaning itself, if that makes sense. Like the speech is symbolic, language is representing meaning symbolically, like in that it's pointing to some experience. But music seems to be inherently meaningful. I don't know.
Yeah, but I think that Ian's point of view is that language is both right and left hemisphere in that some language functions do seem to be biased towards the left hemisphere, but again, these are often decontextualized. So it's the actual motor movements and the phonemes of speech, whereas putting it all together, giving it context, is something that the right hemisphere does. And it's that understanding. And the prosody is
Mm,
very much of a right hemisphere function. And it's really kind of funny in speech pathology when people who study aphasia, they really focus on the left hemisphere because when you have a left hemisphere lesion, people have a difficulty actually producing the sounds. And so they have difficulty speaking, but there is so much emphasis on that part of it without really thinking about all of the functions of language that are still available through the right hemisphere and
mm,
especially through music. And speech pathologists have used melodic intonation therapy for years. And because that's a strategy that is accessible. And so that or with stuttering that people are able to speak if they put it in a
yeah.
musical context and a melody. So I think that it really speaks to the fact that, as speech pathologists and as people working with aphasia, we have to be thinking about what I think McGilchrist really argues, which is that language it happens in both hemispheres and actually involves a lot of the brain altogether. And we yet because we are so sort of deconstructionist in our thinking, we think, oh well, language occurs here in Broca's area or in
Mhm.
Wernicke's area, but it's so much more than that.
Yeah, thank you for that reframe. Yeah, it's amazing seeing it firsthand. And I've used MIT, the melodic intonation therapy, a lot for young kids learning language too, especially autistic kids who seem to have trouble learning language. Somehow, the melodic scaffolding of a phrase is just an amazing way to learn language. And yeah, it's something that we don't really, when we think about speech and language, it's like that the melodic aspect of language isn't even talked about. You don't consider language to have any prosody usually, unless you're like a Mandarin speaker or something like that.
And then because you're thinking about the semantics and the syntax, but you're not, the emotional aspect and the intent and the nuance and the idea of are you um, are you creating a metaphor or are you making a joke? These are all things that happen in language, and they really are not left hemisphere, but right hemisphere based.
Yeah, there's something that Ian says about the hemisphere differences that I was thinking about the other day in terms of pragmatics was that left hemisphere always wants to collapse to a certainty. It can't deal with uncertainty or openness or like double meanings. Whereas like in the right hemisphere, which is dealing with the more may arguably important parts of language, which are like the ability to understand another perspective, another communication partner's intention, and the fact that there can be multiple meanings at once, I think is just so important because that is it's obvious when it's not there, but it's so overlooked when we use it naturally. We don't even consider that to be a fundamental aspect of language, but that ability to keep your mind open to multiple possibilities is, yeah, super fundamental. Well, I wanted to go over just really briefly in the chapter you talk about like, a little bit of the history of science studying the musician's brain. I was wondering if you could talk a little bit about the German surgeon who started looking at musicians' brains.
Yeah. I think there has been this tendency in science to, this question always of where in the brain is something happening. And, first people used phrenology, so just the bumps on the head would be able to say, okay, well, a person with a bump here on the head or there on the head, would be more likely to have this or that trait. And in the end, phrenology hasn't really taught us all that much, but sort of the modern day phrenology is imaging. And so we think that because some area of the brain is active during a particular task, that whatever it is, the task is happening in that area, which is really not the case at all. I mean, first of all, with imaging, you're measuring blood flow. You're not even measuring neural activity. You're measuring blood flow, and just because a particular part of the brain may be active, what about all the parts that you're not picking up with your imaging or that are active and you're not picking up or are not active? And that's as important as what is active.
Yeah.
So we've been sort of going sideways a little bit. But that said, people have done autopsies on the brains of famous people and have made various claims, that I don't know, Beethoven had certain cerebral convolutions that was more than typical. I mean, who knows? Um, and but there have been studies showing that in fact certain brain areas seem more developed in musicians compared to non-musicians. So, for example, in a pianist who uses both hands, the motor cortex activity is more symmetric in people who play the piano than in a violin player. And, the violinist is this wonderful example of, so much of the fine motor movement that you do as a violinist is in the left hand. And so if you compare the left and the right sides of the brain with respect to where the right and the left hands project, you find that in a violinist, the motor representation of the left hand is larger than the motor representation of the right hand, which is doing a more, maybe a more sweeping, these broader strokes than these intricate finger movements. There have been studies showing that some of the neural connections, the corpus callosum, some of the fiber tracts seem to be larger, more myelinated in people who make music, which, I think just makes sense to the extent that if it is the case that making music engages so much of your brain, a lot of the fiber tracts, of course, connect one part of the nervous system with another. And so, we do know that the more you use certain parts of the brain or you do certain activities, all of that wonderful work that was done in animal models, just showing that, if you um, overuse certain digits in monkeys, for example, those parts of the brain become larger, or if you amputate digits, the parts of the brain that used to be associated with those digits now becomes associated with other parts of the hand. So,
Mm.
there's a tremendous amount of plasticity that happens all the time that again relates to use. And the motor system is a really obvious one because the motor system actually has this mapping of the body and all the body parts in the brain, so you can really see how certain activities are going to enhance the representation of certain parts of the body more than others. Some of the most important work was not imaging at all, but was work that Helen Neville did in deaf people, finding that in deaf individuals, their auditory cortex responded to visual information much more so than in a person who is hearing, because if you're not getting the information through hearing, you're getting language and communication information through your other senses. And so those aspects get taken over, and you see that the auditory cortex in a deaf person is very, very active in response to visual stimulation.
Is that visual information, is it limited to sign language, like something that's representational, or is the auditory cortex responding to like all visual information?
It seems to be visual information in general, in that what is particularly malleable is the visual peripheral space. So, there is the direct foveal vision, which is when you're looking at something straight ahead. And then there is all of the peripheral space. And it's in particular the mapping of that peripheral visual space that gets very enhanced and enlarged in a person who is deaf and uses visual information, whether it's sign language or any visual information. Actually, these are some parts of space. Now we're talking about auditory space. In conductors, their ability to perceive, and also parts of their brain that respond to um, sounds that are occurring in space, in the periphery, not straight ahead, is enhanced in a conductor, because a conductor, of course, is spending so much time localizing sound in space.
Yeah. they're getting close to the owl-like sound
Yeah.
localization.
Well, yeah, I mean, I think that that's why we are so intrigued by the owl story because it really shows us on a cellular level what seems to be happening on a macro level as well in the brain.
It's so amazing that all of these areas, and you break it down really nicely in the book, but that all of these areas are affected by music, and that there's this sort of broad, even domain general sort of changes in the brain that happen from auditory stimuli. And again, I think that's getting back to a bit too modular of a view. It's like everything's all happening. This is all the brain. It is all, our lived experience. But it is kind of cool to see things that we would typically think of as just being sonic stimuli, obviously affect the sound mind, but also motor cortex. And you even talk about like how attention and memory are affected by music. Can you talk a little bit more about that? How?
Well,
Yeah.
sure. As the premise of sound mind is that the hearing brain is vast and that it engages our cognitive, sensory, motor, and reward systems, right? And so cognitive. So when we think of our cognitive system, what is our cognitive system? It's attention and memory primarily, and how we think and what we know. And so when you make music, you are engaging not only your attention, but you are really engaging your memory a lot. So, think about just as you and I are talking right now, you have to remember what I just said in order to make sense of what I'm saying now.
Mm.
And the same is really true in music. You have to remember what you just heard if you're going to put it into the context of what is coming up, either as you play it and you are thinking about it in your head or you're reading it on a page, but you have to really strengthen your working memory. That's your working memory, is your ability to keep in mind. It's not echoic memory. It's, you know, your ability to kind of keep in mind and manipulate certain sounds that are happening in the short term. And in many, many studies, in fact, one just recently came out in Ear and Hearing, but there have been many, many studies, including some that we've done in my own lab, showing that musicians really have very strong auditory working memory, and that so this is going to be important for music as well as for speech, of course.
And I like that you mentioned also musical improvisation in the book as well. So kind of expanding to creativity too. So like
Yeah,
Herbie, I think there's an fMRI study with Herbie doing some improvisation,
yeah.
and they're talking about how what is the frontal cortices that are sort of shut off when you're really in flow in
Yeah,
improvisation.
so this is a lot of the work that Charles Lim has done. And he is an otologist and a scientist, and he has done a number of experiments of musicians improvising in an MRI scanner. And what he finds is that when they're improvising, their areas of their frontal cortex that is usually active and is associated with self-awareness become rather silent. And so, you can imagine that there is not very much monitoring of what is going on, but so, not a lot of self-consciousness, if you will, but that there is that improvisation relies on pulling together information that has been previously learned, and now you're putting it together in the context of what's happening in the music in the moment. And as Herbie Hancock says, he practices all kinds of exercises and plays music all the time, for many hours a day in a directed manner. And he can tell you, okay, at this time I'm playing these scales, or I'm doing this or that. But when he's improvising, he says he just really what is happening. He can't break it down at all. It's a complete mystery to him. And I
Yeah.
think that's kind of part of the beauty and part of what I think we were talking about, the beauty of the right hemisphere, or the beauty of not being able to just pinpoint, oh, it is this activity and this function happening in this part of the brain, but rather it is a making of connections that we really cannot grasp in a reductionistic manner.
Yeah. I don't know if you've had this experience playing music, but definitely resonates. Like I definitely have the all of the experiences where maybe I'm on stage and I'm extra nervous and there's a voice, I need to play something right, or I'm thinking too much about one thing and there's the voice that's trying to control the performance. And then that always, you never reach that magical zone there. But every once in a while when all the conditions are right, everything just drops away and you're like completely engaged. I think this happens in good conversation too, and in where you're just totally in the moment and you're not worried about what other people are thinking about the conversation or something like that. Do you know if there's any studies actually that have looked at the analog between hitting the zone, I guess, in music versus in something like conversation or some other?
I don't. I don't. All I really know about are because it's a little bit harder in language to know. I mean, when we speak, we're everyday improvisers, right?
Yeah,
I mean,
yeah.
but the extent to which we are improvising more or less is much more difficult to gauge than certainly in music when you are making something up that you aren't especially, directing or thinking about.
And it's so rewarding when you are able to do that. You also mentioned reward, auditory reward. There's a study you mentioned that was so cool related to trying to connect kind of the reward circuitry with music, like the money that someone would pay for music. So like the amount that you value it in your brain, so to speak. So like the amount of neurochemicals that were released, I think it was dopamine in response to listening to music, actually mapped to the physical amount of money that you would pay for some song that you liked. I thought that
Yeah.
was interesting.
Yeah. I mean, it's this is a lot of the work that the Zatorre Lab has done, but really finding that both neurochemically and in terms of the neural pathways, the so-called reward pathways that are active during various pleasurable activities are the same pathways that are active when you're making music. And yes, the particular experiment that you're talking about is the participants were asked to rate particular songs, or to say how much money would you be willing to pay for this song versus that song. And at the same time, they were then measuring the neural activity when this song or that song was going on, and finding that the reward circuitry was more engaged when the people were more likely to pay more money for a song, or they especially enjoyed the song, so that there's this overlap of the reward, the enjoyment, however you want to measure it, but that it does certainly seem to involve some overlapping circuitry. And it's interesting also how some of this circuitry and the neural transmitters are activated, even if you know a piece of music, for example, and you're anticipating a musical climax, even before that part of the piece it happens, you know that it's going to happen. And so there's this buildup of activity in the brain that is happening even before you get to that particular part in the music.
So interesting. One thing I've wondered about too is how if our listening habits, and they must, because again, biologically we are what we do, but if our listening habits, especially like in the younger generations, are changing our brain's response to music, because and I'll give you an example of why I'm thinking that, but with the streaming services that became so prominent, Things like SoundCloud, for example, is a streaming service for music, and it gives you the sound bar. And number one, there's like an infinite number of new songs. It's just like a never ending stream of new stuff. And their songs are getting shorter and shorter. And you can see where a lot of people who like, electronic music, for example, will like, they want to hear when the music drops. So they will fast forward. Like I see this behavior both in myself and in a lot of people I know. They'll just see the sound wave file, and they'll just fast forward to the part that like is the main quote unquote part of the song. And so it seems like there's this shortening of attention, and also kind of like the super stimulus thing going on where we're getting shorter and shorter bursts of rewarding stimuli that aren't as substantive, if that makes sense. Because
Yeah.
we're if you listen to a whole album, which I used to do but like don't do as much anymore, it's like there's a different level of reward and learning that you get from engaging your attention for that long.
Yeah, absolutely. And that's, I think, one of the things that making music it's different from passively listening to music, but when you're trying to learn something, it really does, no matter, you can't just fast forward to having learned something. You have to do it again and again and again, and you have to engage your attention. And so you're training your attentional skills for longer and longer attention spans if you are motivated to learn a piece of music or motivated to do whatever thing, it's going to require that you pay a lot of attention to it. But I think that our attention spans are really something that we can work on and that we can hone, and we can hone in our children. For example, children love to be read to, and adults like to be read to as well. I mean, and I listen to many books, audiobooks, and whether you are reading it or you are listening to it, you are strengthening your attention. But certainly as you're listening, you are strengthening your auditory attention. So right now I'm listening to the Odyssey, and the Odyssey was very much meant to be spoken and to be
Right.
heard, not to be read.
It was like bards, like the ancient poets
Yeah,
that used to.
they're songs.
Yeah. Yeah.
And so it's a long song, and you just need to listen and listen and listen, and it's pretty great.
We like to think as modern people that, oh, we're so advanced in so many ways, but to think back to the amount of attention and memory and cognitive skill it would take to recite the Odyssey in verse by heart,
Yeah,
that's an incredible
which
feat.
certainly, I mean, my parents were, in school, they had to recite a lot of important poetry. They had to learn it. And I think that, this is another way in which we have just such, again, I'm looking for that word that I still haven't been able to find, but that we're so misguided in thinking that modern man is more developed, when in so many ways primitive man was so much smarter, and paid attention to all kinds of things like the stars and the tides and the seasons, and could listen to long stories and remember them. And I think that so-called primitive man was so much more sophisticated than so-called modern man is.
Well, I mean, it makes total sense if again, back to the one of the cruxes of the book, like biologically we are what we do. If you have to do hard stuff all the time,
Mhm.
your abilities are going to be enhanced. And I think a lot of modern medicine and a lot of the things we have are fantastic, and wouldn't want to live without them. But certain things make life too easy, and make it. There's so many back to the Odyssey, there's so many sirens out there that are calling for our attention that draw us in and sort of reduce our attentional capacities. That we do have to be careful about it. But it's hopeful in a way, in that both what you're doing and what Ian's doing is shining a light on what are these things that are changing our attentional capacity in the
But
sonic
also
world.
the idea that stress is important. So there was a wonderful experiment that was done a number of years ago. It was a collaborative experiment across 30 countries where they created a biodome where they were interested in just learning about the different conditions for life that were necessary, especially for plants and trees to grow. And what they found is that after a while, the trees just kept falling, and they realized it was because there was no wind. And you need that constant stress of the wind to develop the strength in the roots or whatever it is that keeps a great big tree up.
Oh, so cool.
Learning to strengthen anything takes energy, takes time, takes resources. Making music is one of those things. The stress of it, where it's often not the most pleasurable thing in the world when you're frustrated and trying to learn something and you're having a hard time learning it, or you're told to practice your instrument as a kid. You may not like it, but it creates a certain resilience.
When I think back to some of the things that were both the most frustrating and the most formative and important for my musical journey were the times that I remember one time that I'd been playing for a long time, ever since I was a kid. And the sophomore in high school, I went to this new guitar teacher, and he was saying, "You for this music, you need to totally change how you're holding the neck. Like, you can't do any of these chord shapes like the way you're holding it. It's totally wrong, and you have to relearn this." And I remember like having a breakdown, going home and just thinking like all of this is wasted. But I don't know what it was. I guess the love of music and having gone through a lot of stuff before, it's like I decided to actually go through that process of changing, and that was huge. That was one of the big turning points I remember in my playing, and it was really important to go through that moment of stress. And you mentioned music medicine at the end, and it's funny that it just it's like the nature example. It's so important for us, and the fact that we need to rethink of it as medicine, as a way to like get music back into our lives, is sort of funny because it's so important. But it is, it's medicine. Like, movement is medicine, or natural food can be medicine, or walks in nature.
And I think what I really am hoping is that your audience of speech pathologists will increasingly consider music and rhythm or strengthening language skills.
Absolutely. And it is already, something that we are somewhat familiar with, but I think it's only like we only think about it in stroke patients for MIT, or, we've like shuffled them off into these boxes when, you know, we don't even really, I mean, there's a vague boundary already between speech and music. Like, it's organized sound. We should be thinking about things in that, with that framing, which I think your book is helping to eliminate. It's like, it's all the sound mind. Maybe can you talk a little bit about the monks in France who stopped chanting? Maybe we'll stop there, but I think it's kind of a fun
Yeah.
little anecdote.
So at one point, there was some kind of an edict about that the monks had to stop chanting, the Benedictine monks. And what was noted was that after they stopped chanting, the monks started becoming ill, physically ill, and psychologically, mentally depressed. And so this whole order of monks was in great danger. And when they were again allowed to resume their singing and their chanting, they were healthy again. So, there's a huge music and health, music and medicine connection. I really want to um, draw anybody who's listening to a book that Renee Fleming recently wrote, and it's called Music and Mind. And she talks a lot about music medicine, and she has music therapists and clinicians of various kinds. She has musicians and scientists all kind of speaking to this idea of music in medicine, for movement disorders, for Parkinson's disease. Dancing seems to be tremendously helpful. Um, and even for balance and dizziness, dancing, seems to be something that can help strengthen those pathways. But I think that um, the deployment of music in medicine is in its infancy, and it really should be something that is much, much more in the mainstream of medicine, I think.
Hmm.
And, there's certainly every biological reason, as, I discussed in the chapter that we were discussing today, there's every biological reason why making music, and you don't have to be good. It's not about being good at all. It's just making music. And we all love to sing or to clap or to move with the music. And has so many health benefits.
Yeah, I think it gets in the way. Sometimes we think, oh, we're listening to music or we're singing or we're not doing anything productive, and it's just an excuse to, and a reframe excuse to, listen to the music you love because, it turns out it can be one of the most productive things that you do. And I think certainly in getting our kids comfortable in therapy for all the speech therapists listening, I think it's an important practice. So yeah, thank you so much, Nina. That was fun,
Yeah, it was a lot of fun.
and I'll see you next
See you
week.
next week. All
Yeah.
right. You
All
take
right.
care.
Take care.